All right, show and tell. My 3.4 kilowatt hour lithium ion battery. I got 5 of them. Each one of them is the 3.4 kilowatts, not combined. I've been using them all for testing. I've made some component switching, ports changing, fans changing, looking what's the best combination. Fully charge up one battery, and that one would charge the next one, and then the next one, which would deplete the next one. And then you find and learn some of the challenges, things I had to overcome. Sourcing parts has been half the battle. But now, after about 6 months, I've been able to get it down that it's, I'm not going to say stable, but I'm going to say it's reliable. There's now not so many hiccups, and it's something where I can feel confident putting it out into the marketplace. Where the fans go, what thermostats to use, how to keep it cool, when do we need to run it to cool, what MPP to use inside, which ones don't work, what fuses to use, which ones not to use. So I'll stop right there. Let's just talk about the safety and the mindset of the cells inside in the case. So using 1/8 aluminum plate, we've got the cells that are compressed. This way it takes any strain relief off the terminals. And it also, again, I also have a plate underneath, and that would gives it the protection in case this would ever fall. If by some remarkable way you were able to puncture a hole through that, good luck. Can it survive at the back of a half ton? Probably. Down a flight of stairs? Probably. The nice thing is, if it ever does, you don't have to throw the whole thing out because you're worried the case is cracked. Is there a cell that's damaged and I don't know? Do I dare use it? Well, open that case, pull the cells out, do a visual, and if the case is, get a new case if that's the worst case scenario. If you don't think you should repair it, that right of repair is all there. The wiring gauge that I use is the largest gauge that I can possibly fit inside there. It's a multi-strand, so the connectivity is the best. And also then, of course, then it helps with the heat and, the 200 or the 100 to 200 C rating for temperature-wise. It's that's what it's designed for, say like welding cable. The wires, just like this is an example, are loomed, and the smaller ones, because there's a couple BMS's and usually a balancer or two in there, so there's a lot of wiring, and I braid them all nicely. With doing the shielding and that, it makes it, when the battery is being moved, there's eliminate any real chance of wires rubbing together, being pinched, and becoming an open circuit. But these are things that when you flip open the case, you have the ability to view it and see it. It's if the cells you think is the improvements, because hopefully this is just the start. In 5 years we'll have something better. 10 years for sure we'll have something better. This can all be updated or upgraded, and hopefully the cells are even cheaper then. Terminals can be chosen, and the main terminals can be chosen. I think most of the secondary ones is not as important what direction we go with that, but The main terminals are, so we have an Anderson 120 on this one, and this is the traditional ports, so positive and negative with a nice little cover on it. If you do want to put 2-volt 12-volt batteries into series to make a 24-volt setup, then this direction you'll have to go, and give me the direction on that means then I would have to choose the BMS accordingly. The other side, I shouldn't have sat down. Oh, this side here, I have an XT60, XT90, two XT60s with a little cover on it. The XT60s are for the two MPPT charge controllers that are in there. They are 20 amps, 22. They have to be cooled, and the fan inside there is on a thermostat, and the thermostat you get to change according to you would set it, but if you never want the fan to come on, you can do that so that the battery stays pretty much quiet, but the fans are going to kick on probably around 30 degrees when your MPPT kicks in. And at the end of the video, I'll have the batteries outside with 4 panels, 460 watt panels, and we'll show the power coming in. I'm not going to worry about whether it's a cloudy day or anything like that, but I'll give you an idea of the sense of how easy it is to set up, and be able to show that on the, say, on the app and on the screen, the power coming in and how user-friendly it really is. Okay, so I'll pause there. There is more than one BMS. Without question, there has to be a BMS. But what happens if and when it fails? 5 years from now? 10 years? And yes, it will fail. Sad to say, doesn't everything eventually? It's going to have a hiccup. Maybe you played with the settings and were not put back. Isn't it better to have a backup, a fail-safe to catch it? Series electrical storage. Is one BMS all that you want to trust with your well-being? That's pretty melodramatic, but I just want you to think about it. So the main BMS, the 200 amp one, is designed to disconnect the load if that amount is exceeded, just like the 200 amp breaker that's in it. That BMS monitors the cells and will disconnect the load if the cells get higher than 3.6 volts or lower than 2.6 volts. It's also connected to the screen. On the screen, it'll just show the state of charge, how much capacity is left. It'll show how much power is coming in or how much power is going out. It'll display the individual voltage of each cell, and you can turn the whole battery on or off with the screen. This is all duplicated in the Bluetooth app. The second BMS is 45 amps. It might be able to go bigger, but its capacity is also based on the gauge of the charging cables inside. Please take advantage of the second level of safety and security. When you charge using the MPPT through the XT60 or using the XT90, you don't have to use them, but if you can, this will give you that second BMS to double your protection. And it's set at 3.65 or 2.55. It has to be lower than the main one. I want the main one to do 99% of the work, but if it has a glitch, there's that backup, and the second one is there. And I'm always way more concerned with overcharging the battery cells than I am over discharging them. Take a pause there. All right, here is the Bluetooth app. And what it's doing right now is it's cycling through by way of connecting, disconnecting, reconnecting to the next battery, and giving you basically an overall of what all the, if you have multiple batteries, what each one's doing. It's a nice little snapshot. And then if you want to go into depth into one of the batteries, so you can see how much you're charging by or not charging by. In this case, it's 0. There's the voltage state of each cell. And this is, I can go and show you the configurations, but I don't see the point. And then I'll show you on my watch. So, okay. And it's got a decent range to it as well. So if you're in your trailer or your boat, you'll definitely be able to read it throughout the cabin. Why would I want to build such a large battery pack in a toolbox case? The case is very robust. It's even hard to scratch. The cells that are in them are rated for over 6,000 cycles. That's over 10 years, just like the case. We want them to last a long time. The serviceability, because you can open up the case lid, check in the fuses, check in the cells. The handle gives you the ability to move it throughout the house, whether to the basement or take it to the trailer. It's somewhere around 60 pounds, and that's why I think it's better that the inverter is not included with it. It makes the weight transfer manageable for one person. You're going to make more than one trip. And in this case here, it's a modular design. We can add to it. We can stack things onto it. We're only going to be able to stack 2 batteries on top of one another just because of the weight constraints that the case has. No screen will be able to be put on there, so I need to know that in advance. But we can take the screen, put an RG45 onto it, and you can take the screen and you can move it around wherever you want. So if you have a boat and you want to put this as your trolling motor, there you go. You want something that's not just stationary. You want something that you can use in multiple places, whether it's at work or at play. I want to build a couple of examples and just show you why I think it's a better setup than just having an all-in-one. So if you can imagine having a couple of these, and maybe you'll have one in your cargo trailer, maybe you have one in your fifth wheel, maybe you have one in your back of your van. It's designed to be bolted down, and it stays there. It's these things that come in there and click in, and then it's stationary. I think that's a big improvement over a tie-down strap. So I've just charged this up. Now I'm going to be taking it to my van. Okay, till I hear the click. Okay, now there's more. I'm going to take the same mindset, which is using the inverter to click in as well. So now this is locked this down, is locked this down. It's not going anywhere. And I should have showed you an example of this. Let me take this off. I wanted to show you how robust this thing is. So hopefully your boat or trailer never becomes upside down. Okay. Using an Anderson connection means that I've already set myself up. What used to take well over an hour, I've done in just a few seconds. This is a great setup in your camper van. I've got 2000 watts, clearly run anything such as my coffee machine, and because this doesn't even use the inverter, my DC fridge. Now if you're at work, and you want to run a vacuum cleaner and a sander, this microphone is noise canceling, so you'll hear it initially start, but you'll have to take my word and I'll visually get close enough so hopefully you can see that it's actually running. Vacuum. And in my first video there, I was showing how much power draw that was, and as you know, it's playing with 1500 watts. So I'll leave that there. Let's build something bigger. Doesn't mean it's better. Now I want to use the air compressor, but I also want to be able to show it to you on the clamp meter. So I just think this would be ideal for someone who has a trade show booth, a pavilion, and doesn't want extension cords running all over. Now you can bring your own power to the party. Okay, and modular. I can handle the weight of each item. So if I got to go through an elevator, flight of stairs, an escalator, I can do one at a time. You hear that click? So it's in. People make 3D printed parts, so I could do the same thing, except it won't click into place. But I just want a table, I can do that. All right, inverter on. One of the hardest things to run is an air compressor or air conditioner. It's that surge, that startup, that can be quite brutal. I'm going to go through here. Vacuum cleaner. Oop, 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 oop. Slow down. Okay. Now, we will need to change the camera a little bit. Amps. So DC, and we need to zero it. Okay. I need to grab both positives. Oh, I already switched it to AC by doing that, so DC 0. Okay, 137. Okay, you're going to have to squint a little. Air compressor. Oh, I put the switch on the wrong side. still need to do through here. So note the inrush. See my hand? Good. Okay. Hope you can get a sense of why I think it's such a flexible setup. I will then tomorrow get the batteries, just the one, and I'll set it up with some solar panels and show you the MPPT part. And I'll splice that in and we'll do it.
Oops, I forgot something. I wanted to show this port for charging. So turning any of these things into a real smart charger. Any charger that you have, pretty much any charger that you have. I have found a couple of exceptions. But turning your charger into a power supply. So the problem is chargers, as I said with my other videos, only read the overall state of charge. So between that 11 volt to the 15 volt. But that doesn't do us any good. We need to know each cell. We can't overcharge a cell. So using this device here, okay, let's just zoom in a little. Okay. I've set up the parameters, specifically LifePo4 and the conditions where I want it doesn't even ask me what the end charge between the 11 or 15. It just asks me what's the end charge I want the cell, any of the cells, so that they will all reach 3.55 all at the same time. So I'm going to go hit confirm, scroll up, and you'll see that there's no cells there. Okay, no reading. Let's plug it in. Okay. And now you can see that it's got you can read each cell, okay? Now, I'm using this little power supply, and then I have to take this end okay. So we got the power supply going through it. And this is now the controller, okay? Doop. And I'm gonna have it go up to 26.6. And I know I'm repeating myself from my other builds, but as it gets to the top of the charge, when the cells get to that 3.5, it'll ramp the controller will ramp this power supply down so that the cells have the ability to absorb or float. So we will call this bulk right now as it charges at 26 amps. And then when it gets close to that 3.5, it'll ramp it down to maybe just 1 or 2 amps so that all the cells will become even. All right. Now, let's go outside. Okay, so here's the quick and dirty. This would be something like I would set up at my trailer as you know, I have the panels on top of the trailers, but the supplement to get them out from under that tree canopy. I used to use these things, but I just found that I might as well just build my own little frame off of it, and then I'm not carrying anything else. One less thing, I should say. Okay, so we're gonna hook up the 2 panels. And right now, so there's the color display, and I hope you can see that it's not bringing in any solar in. Okay, and so you go to 2, and what I'll do is after I hook it up, I'll go through the menus too. Okay. All right. So I can always provide these, but this is, of course, then to supply to any. Here's the 2 ports. One. Slide it in to get to the second one. So they're just, everything's in parallel here. Okay, so 35 amps coming in right now. So if I go to page 2, this is where you can turn the inverter on or off, temperature wise. Okay, page 3, the cell voltage. Okay, page 1. And why I left it so that you can turn the temperature up and down is if you're getting solar, I would turn the temperature down so that it cools the MPPT in it. If you're not collecting solar and you're just using it as a battery, just turn it right down. You don't need it on. The cells won't generally develop enough heat. And then the beauty, of course, is you're never listening to a fan. So again, that goes into these 2 ports here. Okay, so not bad. That's 35 amps. It's coming in. And you won't hear that fan until this temperature comes up to about 23 degrees. And I have the temperature set right beside that MPPT, so you can fully keep on top of it. So the max that you're supposed to do with these is 42 amps. Okay, that's 4 minutes, so I'm going to shut her down. Simple as that.